Greetings and welcome, friends. Today we're talking about dividing polynomials. You already know how to add, subtract, and multiply them. Why not learn one more skill? The first type of example I'm going to talk about is specifically dividing by a monomial. Dividing by a monomial. All right, which is easier than the alternatives. But let's just jump right into it. So let's say I was taking the following. What if I have 6x cubed y squared minus 18x squared y plus, and I don't know, 32 sounds good, xy cubed? Sure, there we go. And I want to divide this all by a monomial, so a single term, right? So let's say I want to divide by, I don't know, 2. Yeah, 2 would have been nice. 4xy, how about that? So one of the techniques you could do, all right, just like we had distribution when we multiplied by a monomial, I could kind of distribute this division-ish, where I'll just like put this underneath each of these terms. So it's kind of like distribution, I suppose. So let's do that. Let's write this as 6x cubed y squared over 4xy minus 18x squared y over 4xy. And plus 32xy cubed over 4xy. There we go. And now I can treat each of these as kind of their own individual simplification. So let's do that. So between 4 and 6, I could partially reduce those by 2. 2 goes into 4 twice, into 6 thrice. Between these x's, what do I doodly? Yeah, subtract the little guy from the big guy. And between the y's, let's do the same, right? That was a gross error. There we go. Let me simplify this one first. So this would be 3x squared y all over 2, if I'm not mistaken. Now let's work on the next one. Between 4 and 18, 2 goes into both of those. 2 goes into 4 twice and into 18 9 times. Between the x's, subtract the little guy from the big guy, move him upstairs. Between the y's, I guess you could just cancel those out there a little bit. So we'll have minus 9x over 2, I think. Agree? Right? 2 minus 1, little invisible exponent, is 1. And for the last one here, between 4 and 32, 4 goes into 4 once, into 32 8 times. Looks like the x's cancel out this time. And the y's, subtract the little guy from the big guy. So I could have positive 8y squared. All right, so that's one way you can do division. Bless you. Bless you. So that's how you can divide by a monomial. All right, it works okay, right? It's good. But let's talk about dun 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 long division, which, as was mentioned but moments ago, you probably have not thought of it since the days of 3rd grade, maybe 4th grade even. So let's recall. Let's pretend we're 3rd or 4th graders right now, and let's learn this. What if I wanted to divide, I don't know, now I can't think of a good problem. What if I wanted to figure out how many times does 6 go into, I don't know, 724? Does that sound good? That sounds like something you could do, right? So this little symbol right here is my division symbol, right? Let's see. So let's do this. So does anyone remember how to do this? Okay, so it turns out there's a process. Does anyone remember the process? There's a 4-step process that repeats. Anybody? Okay, so the first step in long division is you divide. The next step is you multiply. Third step.
Then moves on something. Subtract. Add, not add,
bring down.
Yeah, I remember that.
And you repeat. So apparently, dead men smell bad. Wow, that sounds like an accurate statement as well, I assume. Eventually. Okay, dead men smell bad. There you go. And I've got this little vinculum over it suggesting that we repeat the process. Right? So you do all 4 steps, and if you're not done, repeat. Do all 4 steps. If you're not done, repeat. Right? So let's do that. So the first thing I do is divide. So how many times does 6 go into 7? 1 time. I'm going to write that over here, 1 space over from the 7's column. Right? Let's see. Next step is multiply. Right? So multiply. 1 times 6 is 6. All right, that's the multiply step. You write that under the same column as the 7's. Next step is subtract. So I draw this little subtract bar here. 7 minus 6 is 1. So that was subtract. Bring it around town, right? Bam. So there's bring down the 2. So I've completed 1 full cycle of divide, multiply, subtract, bring down. So let's do it again. So this time I'm going to figure out how many times does 6 go into 1? No, actually better yet, how many times does 6 go into 12?
2.
Twice. Right? So I write it kind of 1 column over from my little 12 down here because this is in that column, right? So that's divide. Next step, multiply.
6 times 2 is 12.
12, okay, I'll write that down here. And subtract. And then bring down. 4. So I could say that my answer is 12 with a remainder of 4.
Wait, why is it 12? Wouldn't it be like 120? It'd be like 120 something, right?
Oh, yeah, wait a minute. Rip. Yeah, I messed up clearly. That's funny. Uh-oh. So, alright. So we've got so it doesn't fit. Alright, you know what I did? I put these in the wrong spaces. Ooh, that's embarrassing. Let me fix it. Yeah, look at this. Let's see, rewind. Good call. Now what our friend Hank did there was he checked the reasonability of our answer, and he was like, no, that doesn't work. We're off by like a factor of 100. And that's a good idea. I like that. So, so 6 goes into 4. It doesn't. So what do you guys do? 0.0. Right, so since it didn't fit in, I have to throw the 0 there. And now I can bring down this 0. 6 goes into 40 how many times? 6 times. This decimal point lands right there. And let's see, then a multiply. 6 times 6 is 36. Subtract, right? So that's 4. And it's going to have the same issue. Bring down 40. Yeah, it looks like it's going to repeat this process. Right? Or what I could have said when I got this 4, let's see, where would it have been? Yeah, I would have failed in having it go in there. It would have been 120 with a remainder of 4. That's the... And another way you can write your remainder is 4 over this number right here. So 4/6. which I want to point out 120 plus 4/6. 4/6 is 2/3 or 0.6 repeating, right? So this is kind of one way you could write your remainder like that. So you've seen this before. Clearly, our memory, even my own, was a little bit fuzzy on how to do some of it. But we're now going to do the same thing, but with polynomials. And it's going to be amazing. Hello?
Man,
Is someone knocking on my door?
should I let them in?
Nah, I think we're cool. So let's figure out this one. What if I'm dividing the following? What if I want to figure out, let's see, where am I? X squared plus 6x plus 8. And let's see, I could actually write this a couple ways. I could write all divided by x plus 3. I could write I could write it this way, divided by x plus 3. That's the same thing, right? Or even check out this way I could write it, and your book's going to write it this way sometimes. I could also multiply it by x plus 3 all to the negative 1. Because what does the negative 1 tell us to do?
We're over 1.
Yeah, move it downstairs. So then it becomes dividing by x plus 3. So I just want to point that out, like all that kind of means the same thing. So x squared plus 6x plus 8 all over x plus 3. So here I'm dividing by a binomial, a two-termed expression. Man, there we go. So I can't use my previous technique. That won't work out that nice. So instead, I'm going to have to use this long division. Hello, can I help you?
Can you give a note to Aaron for me? Because you're his last period class.
Oh, yes. Yes, I may. Thank you. So, this is what we're going to do. I'm going to put x plus 3 on the outside of my little division symbol. On the inside, I'm going to put this little x squared plus 6x plus 8. And we're going to divide. And we're going to divide actually using exactly the same process. Divide, multiply, subtract, bring down, repeat. Okay? That looks scary, I realize. But we're going to be cool, don't you worry. It's going to be cool. So, for the divide step, let me give you this hint. Let's see. Let me actually get the right color I want. Here we go. For the divide step, you're going to divide leading term by leading term. Leading term by leading term. Bam. So, here we go. So the leading term of this guy divided by the leading term of that guy. Now, a lot of students get this first question wrong. What is x squared divided by x? Or I could also say, how many times does x go into x squared? And that's where people get it wrong because they're like twice. But it actually goes in x many times. One of the things I might suggest is actually writing some little scrap work on the side. X squared divided by x. Let's see. Oh, I'd have to... yeah, it'd be x to the first. Right? Do you guys agree? X squared divided by x. Subtract those exponents, x to the first. All right. So I divide the leading term by the leading term, and my answer was x. Where should I write that? In this case, actually, I'll write it above the x's column. This is why I messed up on the previous one. I was thinking too parallel of a concept to dividing by polynomials. So it goes in x many times. So I just did the divide step. Next step is multiply. So I'm going to multiply, ready? This entire thing by this. And I'm going to write my answer down here. Okay? So x times x is x squared. X times 3 is plus 3x. All right, so I distributed. You see that? X times x was x squared. X times 3 was 3x. Agreed? All right, next step is the subtract step. So I'm going to draw my little subtract symbol bar here. And I'm technically subtracting this entire thing. You don't have to write that if you don't want. But it might be helpful. I believe so, right? So x squared minus x squared is 0x squared, so I don't have to write anything there. 6x minus 3x, because remember I'm on the subtract step. 6x minus 3x is 3x. And the last step, bring it down. Bring it around town. Land on your right foot, don't forget it. So I've completed one full cycle of long division, but I'm not done yet. So now I'm going to do it again. Let's divide, and I'm dividing what? The leading term by the leading term. Okay? So 3x divided by x is what? 3. So am I going to write that on top of the other constants, right? This is my constants column, linear column, quadratic column. So I'm going to have plus 3 because it was positive, right? So that was division. Now let's multiply. What am I multiplying? I'm multiplying 3 by both of these guys, and I'm going to write my answers down here. 3x plus 9. And now I'll subtract. Man, you guys are too quick. 3x minus 3x is 0x is 8 minus 9, because this is the subtract step. That's the one place where people often get it wrong here, is negative 1. There's nothing left to be brought down, to be brung. So we're done. Meaning our answer is x plus 3 with a remainder of negative 1. And that's probably weird as a remainder, I imagine. But that's accurate. The other way I could write this is x plus 3 plus, and if you take the remainder and put it over this guy, negative 1 and x plus 3, like so. This is actually what our answer is, right there. So I could also write that as minus 1 over x plus 3 if you wanted, as another way to write it. So, yeah, it's a little bit peculiar, perhaps, you might say. It's a little bit quirky. You guys okay with this so far? It's really the same process. It's just now with letters and stuff. Polynomials. But it's the same idea. Yeah, it's like identical, really. What did I want to say? Did I want to do a check on this? Yeah, I'm going to do a check. Watch this. This is going to be awesome. You don't have to do a check. Now, if this is my answer for how many times this goes into that, I can actually check my answer by taking, all right, my quotient, my answer, multiplying it by my divisor, and that should give me this guy, my dividend. All right, so let's see what happens. So if I multiply x plus 3 times, and I'm just going to write that as minus 1 over x plus 3. Are you guys cool with that slight modification, making this a minus sign and this a plus sign? Okay, just so you know where that comes from. So as a check, let's see what happens. So I've got a binomial multiplied into a trinomial-ish, right? That's kind of a weird third term, but it counts. So let's do some distributing, shall we? So x times x, x times 3. Actually, oh, there's a better way to do this. You know what? I'm going to do this whole thing. Watch this crazy outside of the box distribution here. I'm going to distribute the entire thing into it. Okay? So my first thing, I'll have x times x plus 3, which I'm just going to write as x times x plus 3. This is kind of an abstract way to do it. But you see, I'm taking this whole thing, I'm kind of treating it, even though it's an expression, I'm kind of distributing it as though it was just a term. So x plus 3 times the x. Then I'm going to do x plus 3 times the 3, so that's going to be plus 3 times x plus 3. Right? minus, and then I'll distribute it into this. This one's my favorite. Here we go. This will be 1 over x plus 3 times x plus 3. This is going to be good. That looks crazy though, I know. But watch what happens here. Distribute here, what do I get? X times x is x squared plus 3x. What do I get here? Plus 9. What do I get when I do this? Ready? Watch this. Ready? Whooshing, whooshing. Yeah, minus 1. So let's simplify this. X squared plus. Does that check out? It does. What? What? Craziness. Cha-ching. So a little bit weird on the distribution part. There was another way to do it, but I tried to do it in the way that would have been friendliest to our current abilities. So ready? One more example, and then we're done. Back to the top of the page. Example. Here we go. So let's suppose I want to do this. I want to do, how about this? 6x squared minus, how about, wait, I've got it. 27. And I want to divide that by, let's do 3x plus 9. I think will work nicely. Now, there's one thing I want to point out here. Let's see. So let's try setting this up. So this is my divisor, right? So I'll have 3x plus 9 on the outside. And check this out. 6x squared, right? I'll write that. I'm not going to write minus 27 right now because this is missing something. What would have been in between a 6x squared and a negative 27? If I'm considering or thinking about standard form, x squared, I don't have an x to the first term here. I'm going to write plus 0x minus 27. Now you might not think that's that important, but let's suppose I was dividing 2 into the number 108. Is that going to be the same thing as 2 divided into 18? And be like, that 0 doesn't really matter. I don't need that. Like that's going to be 2 different answers, right? This 0 is a placeholder. It's a significant digit. It matters to the division. Now, would I ever write this though? Would I ever write this? No, because like this 0 doesn't matter to me, right? It's like. Yeah, it's the fact that it's in between that matters, okay? So that's the same thing that's going on here. Whatever my highest degree is, I need to account for every degree less than that down to my constant, okay? If I don't put that there, it's actually really going to mess up my work. All right, so let me point this out. So let's try the setup here. So what we're doing divide, multiply, subtract, bring down. So here we go. Divide, leading term by leading term. 6x squared divided by 3x. I might have my little scrap work off on the side. What do you think that is? 6 divided by 3 is 2. X squared divided by x is x. Which column should I write this in? Yeah, in my linear column, right? My x to the first column. If I didn't have this column represented here, if I didn't have this placeholder, my work ends up getting like crunched together and I really start messing things up bad. Okay? So that's really the primary reason that it has to be there. So let's see, that was my divide step. Now I multiply. So 2x times 3x is 6x squared. 2x times 9 is plus 18x. Okay, so that was multiply. Let's subtract. Let's see. This is... Ooh. This is a super common place for mistake. In fact, on my quiz, I'll have a multiple choice question with a box here. And I'll say, and it'll be a half-done long division problem. And I'll say, what goes in the box? And I'll have possible answers such as 18x. I might have negative 18x. I might have like 18x squared. And I'd probably come up with some other goofy one. But the point is, this is the subtract step, remember? So I'm technically subtracting, right, this entire thing. So 0 minus 18 is going to be negative 18x. And then I can bring down the negative 27. So be careful on that subtract step. It'll get you. It's a sneaky one. So now let's see, I brought down. So now I'm back to divide. What am I dividing? What am I dividing? I've got lots of options here.
18, negative 18x and 3.
Right, leading term by leading term. So negative 18x divided by 3x. Negative 6. Because the x's cancel out. 18 divided by 3. Yep. Hey, it's alright. You saw me make my division mistake earlier. Whew. And that was on video. Ugh. On my website now. Making mistakes. But hey, it's okay to make mistakes, friends, as long as we learn from those mistakes. Let's see. So there's the negative 6. I read the negative 6 conveniently in my constants column. Look at that. That's great. It doesn't have an x. That guy doesn't have an x. They're buddies. And that was divide. Now I'm on multiply. What do I do? Multiply what by what? Yeah, so I'm going to distribute to both of those and write my answers down here. So negative 6 times 3x is... That's nice. Negative 6 times 9 is... Negative 54. Okay. Here we go. Subtract. Negative 18 minus a negative 18 become plus 18. That's just 0. 0 x's. Oxes, right? Yeah. And negative 27 minus a negative 54 is plus 54. I think that's going to be positive 27 if I'm not mistaken, right? So that means my answer is 2x minus 6 with a remainder of 27. What's another way I could write that? Plus 27 over what? 3x plus 9. I won't have us check this one. This video is long enough. Well done, friends. This is long division of polynomials. All right, internet friends, bye-bye.